In this video, I'll walk you through the citytemps.r script, which you can find from the course website. The objective here is just to get a little bit of practice with some of R's basic plotting functions, particular histograms for this case. So first things first, we'll read in the couple of data sets we're going to be working with in this script. They are temperature data over a period of about 15 years for San Diego, California, and Rapid City, South Dakota. You could use these commands right here if you were in the present working directory where you store those files. The easiest way is to avoid that headache and deal with RStudio's import dataset command. Click from text file and surf to whatever directory you've downloaded those text files to. Mine's sitting here in this folder called citytemps. So what I'll do is I'll click on this one first, casandie.text, that's for San Diego, and then click open. And here RStudio gives me a window for importing the data set, and I can change various features to control what it thinks is going on in this text file. So you notice I'm getting an error here. Line 1 did not have 5 elements. That just has to do with the fact that it doesn't know what's separating data values here. So it thinks it's a tab, but it's really just a whole bunch of white space. So I'll change it to white space, and lo and behold, now we've got a valid import. Okay, so that's working. We click import, and it's going to give you this error. I'm not quite sure why, but it's not important. Notice now if I double click here in the workspace pane on the data set name, here it is. It's got the month, the day, the year, and the temperature in degrees Fahrenheit. Let's do the same thing for San Diego, for the Rapid City data. That's in this file here, sdrapcity.txt. Open, same thing, tell it what's separating data values, not a tab, but just generic white space, and we get a valid import here in this screen. Click import, and now we've got both data sets ready to be worked with. Close those. Go back to the citytemps.r script and scroll down here. If you are a weather geek and want to get some more data like this, you can go to these websites here. So the most basic thing you might want to do to look at a data set like this is to simply plot a histogram. So we do that with the hist command. And the way we invoke the temperature data value for the CASANDIE data set is always with the syntax dataset $variable name. Okay, and so I just highlighted this, or you could even just put your cursor on the relevant line and hit Command Enter, and that will load that command down to the console here. And here's our histogram. Not really much to say about it. Okay, one thing you might want to do is to change the title from this fairly generic thing here to something more informative. So, I'll change that to average daily temperatures in San Diego, 1995 to 2011, and I'll do that by encapsulating that string in a set of quotation marks and feeding that to the main flag. So you'll notice what happens if I highlight this and hit Command Enter or Control Enter if you're on a Windows machine. This is a pretty standard thing for our plotting commands. There's a plotting function, there's a data set you're going to plot, and then there's a whole bunch of flags that you add to it to change the visual appearance of the plot. In this case, main tells you what the title is going to be. Okay, let's do the same thing for Rapid City, feeding it a main command to give it a different title. Notice, same thing again, dataset $data value. And now here's our temperatures in Rapid City over here in the plotting window. Okay? So one thing you want to do when you're making plots is to make relevant comparisons. Here an obvious comparison to give you some notion of what the different climates in San Diego and Rapid City are like, or to put those two histograms next to each other. I like aligning the x-axes here because really the temperature axis is the relevant basis for comparison here rather than the frequency axis. So the way we do that is by making multi-frame plots in R. So don't worry too much about this syntax, but for now, just think of it as a function that resets the plotting environment, and it'll give you a multi-frame plot and fill in the plots by row, the MF row. And this C21 is telling me there's a vector with first entry 2, second entry 1 that's giving me a multi-frame plot with 2 rows and 1 column. So this is sort of most easily shown by example. If I highlight this chunk of script here, notice there's 2 plotting commands invoked here, and you'll see what happens. I get an error. Okay, well that was expected. The issue is that this tiny little plotting window over here in RStudio isn't big enough to hold all that, so I have to make it a little bit bigger. You may not have this problem if you're dealing with a bigger monitor or in vanilla R. Okay, so I made that window a little bit bigger, give it a little bit more space here, and let's try these commands again. Cross our fingers. And we've given it enough space. Okay, so this isn't super helpful. It's a little bit scrunched up, but I click on zoom, and now all of a sudden I've got a little bit more informative histogram here. Of course, this is violating many of the basic precepts that we'd like to see from statistical graphics, and that it doesn't facilitate relevant comparisons. The x-axes are different, the y-axes are different, the areas correspond to different real areas in terms of bin width here. So we really need to improve this, and that means we need to get down and dirty with some of R's commands for changing plotting environments, like x limits and y limits, and how many breaks are in a histogram. All right, so let me show you a few of those commands. Scroll down here, starting on line 31. So same command as before, except I'm adding flags to each of these two histogram commands. And that flag is xlim. And I want the lower limit to be -20 and the upper limit to be 100. Even though the San Diego temperatures don't get anywhere near the upper and bottom end of that range, we want to have the same x limits on both histograms. And so this is a pretty common thing you'll need to do in R, is change the limits of a plot. And this is how you do it, xlim or ylim, as we'll see down below. Okay, so I'll highlight that, hit Command Enter, and now you notice it changed here. It's much easier to see the change if I show you the zoomed in plot here. Okay, still different y-axes and still different breaks in terms of how wide a bin on these histograms is, and we'd like to normalize that as well. Let me show you how to do that. Close this, and I'll change the bin sizes so now that the two are comparable across the plots. So there's many ways we can do this in R. Personally, I like to be very explicit about it, which is define a variable that's going to actually tell me where the breaks between adjacent bins lie. So this command seq, S-E-Q, stands for sequence. The way the syntax works is you specify the lower end of the sequence, the upper end of the sequence, and what the increment is, so by equals 2. You notice if I just highlight this alone and hit Command Enter, there that sequence gets spat out to the screen. What I really want to do is store that in a variable, and since it's breaks, I'll store it in a variable called dancing. All right, so now the variable dancing, you can name these things whatever you want, stores the breaks in it, and I feed that as an argument, as a flag to these plotting commands. Okay, so, and you just have to sort of smush all these flags together, separated by commas. Xlim is still the same thing that it was. It comes across lines here, so it's a little bit hard to see. Let me go like this, and now you can see that you've just got breaks equals dancing, xlim equals this, and the dancing variable was defined up here. Okay, and there we are. And now if I zoom in on this, you'll notice we've got similar breaks. Every 2 degrees, we get a break in the histogram. One last thing to worry about here, which is that the y limits are not comparable. So equivalent heights on these two graphs don't mean equivalent frequencies. Let's fix that very quickly. We had xlim, and now we'll use ylim. And you can see we're just move this out even further so you can kind of see all of these on one line here. We're just concatenating one flag after another. We had the xlim, we had the breaks, and now we're going to add after another comma ylim. And you notice that this final parenthesis is the one that closes that one, and R Studio at least has helpful little syntax highlighting so you know when you've actually closed a set of open parentheses. All right, I probably will get an error here. Nope, I'm okay. Let me zoom in. And now we've got similar, in fact, the same y-axis, the same x-axis, and the same bin widths. Now, down here, you can go to town. You just go crazy in terms of how pretty and how involved you want to make R plots. I've given you a lot of those commands in case you want to geek out with R a little bit. Really powerful plotting commands, and really the best way to do it is learn by example if you're interested in using some of this. The plot we just saw is absolutely fine from the purposes of making honest comparisons. But if you wanted to, say, put them on the same plot, add individual text to the plot, change the colors, I've given you some commands that make what I think is also a pretty cool histogram comparison there, putting on the same plot and making one of the colors not quite so opaque. Okay, and there's plenty of other things you can think about doing. I've given you a whole lot of commands down here, but don't feel like you have to go to town on R graphics as long as you make honest comparisons.